On this RAM 1500 Classic with the 5.7HEMI P0032 points to the O2 sensor 1/1 heater circuit reading high. In plain terms, the PCM may be seeing an electrical problem in the heater side of that upstream oxygen sensor circuit. The truck may turn the MIL on, and it can still seem to run normally, but heater operation, emissions control, and fuel control strategy may be affected while the fault is active. The possible fault areas are the heater control wiring, the heater ground side, the O2 sensor heater itself, related connections, or, at the end of the diagnostic path, the PCM. If other codes are present, check what they mean first, then stay focused on proving this heater circuit before condemning anything. Before the circuit testing, know what the scan data can be telling you. The normal range of the O2 sensor output is a 0 to 1. 0-volt analog to digital signal when the sensor is in its normal operating temperature range. In some cases, a contaminated sensor reference chamber can introduce a negative offset output of up to -1.0 volt. Each O2 sensor return circuit has a 2.5-volt bias added, which shifts the signal voltage to between 2.5 volts and 3.5 volts, and on a normally functioning sensor the bias signal voltage should switch between 2.5 and 3.5 volts. If the heater control gets disabled, the affected O2 sensor biased signal voltage can read high, usually stays above 4.0 volts. A small amount of resistance, 3-4 ohms, may not set a heater control circuit DTC, but it can still affect heater operation and cause a sensor signal high DTC. A heater circuit with 4.05 ohms resistance can increase the scan tool heater temperature reading for that sensor by as much as 700 degrees F compared to the other switching 4-wire O2 sensors, and as little as 2.0 ohms can increase the temperature reading approximately 250 degrees F on the scan tool. When a normally operating switching O2 sensor is heated to operating temperature, the typical duty cycle percentage will range between approximately 30 and 50%, and the typical heater temperature will range between approximately 1,200 degrees F and 1,400 degrees F on the scan tool. If there is an issue with the O2 sensor heater or circuitry, the PCM will disable the heater driver and the duty cycle will be 0%. If the O2 sensor signal is shorted to ground and the sensor is cold, scan data can show the bias signal voltage at 0 volts, while the 0-1 raw voltage signal reads -2.5 volts and increases towards 0 volts as the sensor heats up. An open in a sensor return circuit can make the biased signal voltage read high, near 5.0 volts, and the 0-1 raw voltage reading near 2.5 volts for the affected sensor or sensors. If any return circuit is shorted to ground, the biased signal voltage readings for all O2 sensors will switch between 0-1 volt instead of 2.5-3.5 volts. If a sensor return circuit is shorted to voltage, the affected O2 sensors will read 5.0 volts on the biased signal voltage, and the 0-1 raw voltage reading will be 0 volts because the signal circuit voltage and return circuit voltage are both 5.0 volts. Treat those numbers as direction for diagnosis, not as a shortcut around the circuit checks. Start with the basic system checks, then check for any applicable bulletins or PCM software updates tied to this fault. If one applies, perform the applicable repair, then verify the repair and confirm the code stays gone. If nothing applies, scan all modules, record the codes and environmental data, save the scan report, then clear the codes. Turn the ignition off for a minimum of 10.0 seconds, turn it back on, and reproduce the operating conditions that set the code. This monitor is looking at the heater when it is commanded on, with battery voltage between 10.4 and 15.75 volts, and with the heater low fault not active. The set condition is the PCM detecting O2 sensor 1/1 heater circuit resistance above approximately 35.0 ohms. When this fault is active, the MIL will illuminate, and the PCM will disable the O2 sensor heater driver for the remainder of that ignition cycle. An open circuit or direct short to voltage or ground can also leave the heater PWM control disabled for the rest of that ignition cycle, even if an intermittent problem clears itself during that key cycle. If P0032 does not return, treat it as an intermittent condition. If it does return, move into circuit testing. Next, turn the ignition off and disconnect the O2 sensor 1/1 harness connector. Load test the Z908 ground circuit at that sensor connector. Do not load test circuits with components still connected. The load test bulb should be illuminated and bright, and you compare it against a direct connection across the battery. If the bulb is not bright, repair the Z908 ground circuit for an open or high resistance. Then verify the repair and confirm the code stays gone. If the ground circuit carries the load correctly, continue to the heater control circuit. Now disconnect the PCM-side connector and use the GPEC Diagnostic 10436 adapter. Do not probe the PCM harness connectors directly. That can damage the PCM terminals and create a poor terminal-to-pin connection. With the adapter connected, check continuity between the O2 sensor 1/1K99 heater control circuit and all other circuits at the adapter. If you find continuity to another circuit, repair the K99 heater control circuit for a short to the circuit that showed continuity. Then verify the repair and confirm the code stays gone. If there is no continuity to another circuit, keep going. With the GPEC Diagnostic 10436 connected to the proper PCM connector, isolate and load test the O2 sensor 1/1K99 heater control circuit. Keep in mind, the adapter can add up to 1.5 ohms of resistance to the circuit. Again, do not load test with components still connected. The load test bulb should be illuminated and bright compared with a direct battery connection. If it is not bright, repair the K99 heater control circuit for an open or high resistance. Then verify the repair and confirm the code stays gone. If the circuit carries the load correctly, the next check is command versus response at the driver. Reconnect the PCM-side connector, turn the ignition on, and use the scan tool to command the O2 sensor 1/1 control to the maximum allowable percentage. At the O2 sensor 1/1 connector, use a 12-volt test light connected to ground and check the K99 heater control circuit. The light should illuminate when the actuator is commanded on, and brightness will depend on the percentage selected. Then command the actuator OFF at 0%. The light should go out. If the test light responds correctly when commanded on and off, the diagnostic path supports replacing O2 sensor 1/1, followed by repair verification. If the test light does not respond correctly, continue to connection checks before moving any farther. For the final circuit side check, disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Inspect the connector bodies and terminals for seating issues, damaged locks, corrosion, water intrusion, whether seal damage, bent terminals, overheating from poor contact, terminals pushed back in the cavity, spread terminals, and weak terminal tension. Repair anything you find, then reconnect everything fully and make sure the locks are engaged. Clear the codes, operate the vehicle under the same monitored and set conditions, and read codes again. If P0032 does not return, the wiring or poor connection problem has been repaired. If it does return after those checks and repairs, the path supports replacing and programming the PCM, then verifying the repair. The key on P0032 is to prove the ground, prove the heater control circuit under load, check for unwanted continuity, and then confirm the PCM driver response before calling the sensor or PCM. Verify the repair separately and make sure the code stays gone. For more diagnostic training, visit stepdiagnostics.com.